All right, guys, now next thing is, what if we have three-dimensional figures? What if we are talking about geometric solids? What are we going to do next with them? Well, with geometric solids, we still have symmetry with things. Now look down below here. And this is just a rectangular prism. Notice what the plane is doing to it. It's dividing it perfectly in half, which means it has symmetry on both sides. So we do have a type of symmetry with that. That's called plane symmetry. So a three-dimensional figure has plane. Doesn't it almost sound like it's boring, doesn't it? Plane symmetry. Great Gregerson humor, sorry. All right, if a plane can divide the figure into two congruent reflected halves, so I can literally have the same thing on both sides. So this figure has plane symmetry. So that's one type of symmetry. So that's another type for three-dimensional. But we have another one which is kind of cool. It's called axis, or symmetry about an axis. Now, a three-dimensional figure has symmetry about an axis if there's a line which the figure can be rotated on. So basically, as if like if you put a pen or just an axis or a stick through, and if I could rotate all the way around it, it has rotational symmetry. So it's the same idea too, though. If I can go less than 360 degrees, so if I don't have to go all the way around, I'd have rotational symmetry. Now, obviously, this cylinder kind of makes a lot more sense. Like right here, you can have your radius, and when you think about it, I'm just going to show you something that I think is kind of cool. Basically, what this would be is if I was to rotate a single rectangle 360 degrees around using one side on an axis, this is the shape you're going to get, a cylinder. So symmetry about an axis actually helps us in calculus see things three-dimensionally and lets us know that we can work with it in calculus. So it's kind of a cool thing. On this next one, these are a little bit harder to show up for you guys because I actually lightened it when I was copying to hopefully make it easier to read, and I almost lightened it too much. But let's go through and decide if things have plane symmetry or not. Now let me explain this just a little bit. This first one is a regular, if you can see it a little bit more. It's a regular square pyramid. Now the cool thing is, if I was to draw a segment from the top through the center right here, it is very easy to see that I could literally spin it. Like kind of like if I took my pen and put it in one of my solids, I could spin it all the way around. And every 90 degrees I could get that. So does it have symmetry about an axis? Yes, it does have that. So we got symmetry about an axis. Yes. Now, does this have plane symmetry? Now guys, can I take a plane? So like if I was going to do a plane, and could I divide this perfectly in half? There are several different ways you could do this. And one way I like doing it is think about taking the plane that would connect the two far lateral edges and the vertex plane coming straight down. So I go diagonally across the pyramid, and you can see it totally dividing it reflectional on both sides. So yes, this one has both. So this one also has plane symmetry. So both, yay, it works. Now I have this L shape. Now, actually you can see a little bit better if I kept moving so much. Here would be your shape that we're working with. It's a three-dimensional prism with a base that's shaped like an L. I cannot put through the center of this anywhere an axis that it can rotate around. So there has no symmetry about an axis, so no sim about an axis. But could I divide this perfectly in half so it's reflected? And the thing is, yes, I could actually put a plane that would divide it right down the middle, right here. So if you can imagine a big plane coming out, I can't do it very well, but coming across and intersecting it right through there, then you're going to have plane symmetry. So plane symmetry, yes, I can divide it. Now the next one is supposed to be this perfect right cone, which is hard to see the bottom here. So hopefully it's a little bit easier. But you can easily see, because a cone does have an axis, a right cone, that you'd be turning all the way around it, so you can easily go like half a degree even and get axis to symmetry. So we have that. And could I take a plane and use like a cross-section idea and then go right down the middle? Yeah. You could see it basically come out if you were doing it. So that one has both. Now, I'm looking at this next one, and it looks like I have a pyramid with a piece cut out. Now, I cannot, if I put this, my axis of symmetry should be right here. But notice I'd have to go 360, so it doesn't work. But, and actually a student helped me see this one time, because I was having problems visualizing this, but now it makes a lot more sense to me. What if I went diagonally across from this point to my vertex, and I use a plane to cut it in half? I could perfectly divide it out. And so this would actually have plane symmetry. I could cut it. Now, the cool thing is, I wish I had a way to show you this, but literally, you'd have these funky shaped pyramids on each side, but it reflects it perfectly. All right, now we're going to talk about tessellations next, so don't worry about it if it's not perfect, but you guys will do a great job.